The directions say to find the most general antiderivative of the function. So let's go ahead and take a look at example 1. Suppose f of x is equal to the square root of 2. Okay. Recall, the derivative of x with respect to x is equal to 1. So essentially, the derivative of x times the square root of 2 with respect to x will be square root of 2. So capital F of x will equal x times the square root of 2 plus some constant c. So remember, we're trying to think of a function whose derivative is square root of 2. And don't forget, the derivative of x with respect to x is 1. Example 2. Suppose f of x is equal to e squared. Just like in example 1, remember e is a number, e squared is a number. So if I want capital F of x, we go back to this. The derivative of x with respect to x is 1. So the derivative of e squared times x with respect to x will be e squared. And so this is e squared x plus some constant c. Example 3. Suppose f of x is equal to 4x plus 7. So remember, the derivative of x squared with respect to x is 2x. The derivative of x with respect to x is equal to 1. And so if I want capital F of x, so remember, I'm trying to get to 4x. And so if I take 2x and multiply by 2, I get 4x. So if I take x squared and multiply by 2, that will be the correct function whose derivative is 4x. So in other words, here I'm going to get 2x squared plus, now the derivative of x with respect to x is 1. So the derivative of 7 times x with respect to x is 7 times 1. So we're going to get 7x here plus some constant c. That's example 3. Example 4. Suppose f of x is equal to x times 12x plus 8. Now, we need to simplify this, so I need to distribute the x to each term within the parentheses. And when I do that, I get 12x squared plus 8x. And remember, the derivative of x cubed with respect to x is 3x squared. So if you want to think about it this way, isn't 3 times 4 12? So the derivative of 4x cubed with respect to x is 12x squared, which is exactly what I want. So capital F of x is equal to 4x cubed. That's the function whose derivative is 12x squared. And don't forget, the derivative of x squared with respect to x is equal to 2x. And isn't 2 times 4 equal to 8, right? So the derivative of 4x squared with respect to x is equal to 8x. So I'm going to add 4x squared and then just add that constant of integration at the end. And that's example 4. Let's take a look at example 5. Suppose f of x is equal to x minus 5 raised to the second. So the first thing I want to do is square this out. And when I do, I get x squared minus 10x plus 25. And I want to find capital F of x. So don't forget, the derivative of x cubed with respect to x is 3x squared, right? But I want to find the function whose derivative is x squared. And so to counteract that 3, I'm going to divide by 3. So in other words, 1/3 x cubed is the function whose derivative is x squared. So you're either dividing by 3 or multiplying by 1/3, okay? Minus. Now, the derivative of x squared is equal to 2x. But isn't 2 times 5, 10? So what that's going to tell me is that the derivative of 5x squared will equal 10x. So the function whose derivative is 10x will be 5x squared. And then remember that the derivative of x is 1. So the derivative of 25 times x is 25. So I'm going to write a 25x here, and then just add c. That's example 5. So let's take a look at example 6. Suppose I have f of x is equal to 1/5 minus 2 over x. Now, if you don't mind, I'm going to write this as 1/5 minus 2 times 1 over x. Okay? Remember, the derivative of x with respect to x is equal to 1. The derivative of natural log of the absolute value of x with respect to x is 1 over x. And so capital F of x is going to equal 1/5 x minus 2 times natural log of the absolute value of x plus c. And that's the most general antiderivative. Let's take a look at 7. Suppose h of theta is equal to 2 sine theta minus secant squared theta. And I want to find capital H of theta. Well, here's the thing. The derivative with respect to theta of cosine theta is negative sine theta. But I don't want negative sine theta. I want sine theta. And so I have to take that cosine theta and multiply by negative 1. And so this is going to be negative 2 cosine theta. And then the derivative with respect to theta of tangent theta is equal to secant squared theta. So I get to subtract tangent theta and then add c. And that's number 7. Example 8. Suppose f of x is equal to 2 to the x plus 4 times hyperbolic sine of x. Now, let's make sure we remember the derivative of 2 to the x with respect to x is equal to 2 to the x times natural log of 2. But I don't want that natural log of 2, right? So remember, I'm trying to find a function whose derivative is 2 to the x. And so what I need to do is take 2 to the x and then divide by natural log of 2. And that's going to counter this natural log of 2 factor there. And then I'm going to go plus, carry the 4 down, and then the derivative of cosh x, or the derivative of hyperbolic cosine x with respect to x, is hyperbolic sine of x. So I'm going to take 4 times hyperbolic cosine x, and I'm going to add c. Let's take a look at 9. Suppose g of v is 2 cosine of v minus 3 over the square root of 1 minus v squared. And if you don't mind, I'm going to write this as 2 cosine of v minus 3 times, okay, 1 over the square root of 1 minus v squared. So, therefore, g of v is, you're going to get 2 sine of v. Remember that the derivative of sine of v is cosine of v. Minus, remember the 3 carries along for the right. So I'm going to write the 3 down, and I'm going to multiply by the inverse sine of v. And then I just add c at the end. And that's example 9. Let's do one more example for this video. So we'll take a look at example 10. Suppose I ask you the following. Suppose f of x is equal to 2x to the 4th plus 4x cubed minus x divided by x cubed. Now, x can't be 0, so we have to have a restriction. And the restriction here will be x is greater than 0, okay? So we're going to split off that fraction. So f of x is equal to 2x to the 4th over x cubed plus 4x cubed over x cubed minus x over x cubed. And so this is 2x plus 4, the x cubes cancel, minus 1 over x squared. Okay. One thing I want to make note of, the derivative of 1 over x with respect to x is negative 1 over x squared. That's going to come up over and over and over and over and over again. So, let's put this together. So, think of a function whose derivative is 2x. Well, I claim that's x squared. Think of a function whose derivative is, I believe it's 4. Well, that'll be 4x. And then if we think of a function whose derivative is negative 1 over x squared, that's going to be 1 over x, positive 1 over x. And then we just add c. Okay, that'll conclude this video where we found the most general antiderivative of a given function, and we did 10 examples. Thank you.